this is Himabindhu from the Department of IT. So today in this video, I would like to explain about the questions on pushdown automata. So how to design the pushdown automata and how to design the pushdown automata from the context-free grammars. So here in this video, I would like to explain the context-free grammars, how to design from the pushdown automata. So here the input is pushdown automata. In that one, we have a many transition functions. Based on the transition functions, how we are going to design the context-free grammar, we are going to discuss in this video. So before going to how to convert the PDA pushdown automata into a context-free grammar, in the sense we have step-by-step process. So what that indicates? So here we need to main idea is the reverse. Reverse engineering the production from the transition. So here let me briefly explain the context-free grammar, which is having the definition of 4 tuple notation. So one is a V, S, T, P. So in this one, we need to, the context-free grammar is in this form, like, so V is nothing but the non-terminals, how many non-terminals are there in that grammar, and S is nothing but the start symbol, and T is nothing but the terminals, so terminals which are represented with the small letters, and P are the productions. So here we need to derive the productions. So here main in this 4 tuple notation, the fourth one, products are the most important thing. So based on these productions, we can design the grammar. So the productions are grammar is nothing but the equations are in the productions form. So these productions are, we need to derive from the transition function. So this pushdown automata, PDA, so which is equivalent to a Q or M. So M is nothing but pushdown automata machine. So in that one, we have to write the tuple notation. So how many tuple notations for the designing the pushdown automata, in the sense? First one, so we need to write Q. Q is nothing but a finite set of states. And sigma. So sigma is nothing but the terminal symbol. So how many input values are there? Those input values should be represented in the sigma. And next one is a Q naught. So Q naught is the initial state, and tau. Tau is nothing but the symbols which are included in the stack. So what are the symbols we are going to insert into the stack? Those are all represented with the tau symbol. And what are initiation, stack initiation symbol. So stack initiation is required, and the productions. So productions. So these are all the requirement for the construction of PDA. So here, while converting the pushdown automata into a CFG, so pushdown automata, it is having in the form of transitions. So how the transitions are? So let me write the example. Delta of Q naught comma. So Q naught comma. This is the input value. So input value is 1, and top of the stack symbol is, suppose here it is a Z naught. So which having the result as a Q next state. If it is this is the current state and this is the next state. This is current state and next state, which leads to, whenever the input symbol 1 appears, we need to replace it with X, and along with the top of the stack symbol. So what it indicates, the X, while reading the input string 1, we need to replace the 1 with the X, and we need to push the value into the stack. So like this. So here, while reading 1. So this is how the transitions are to be in the form of, in the production pushdown automata, the transitions are in this form. So now this is the input, and here with this input, how we are going to convert into a production. So how the productions are? So S tends to A or S tends to AB or with the terminals like this. So these are the productions. So examples of some productions. So now the what is the task here we are going to do in the sense. So here the input is a pushdown automata and we need to convert it to a productions. So what is the procedure we will see. So how to convert this transition functions into a productions. So main idea is the reverse engineering the productions from the transitions. So previously in the previous videos, we discussed about the conversion from context-free grammar to a pushdown automata. So here, based on that procedure, here it is a reverse engineering. So from transition functions, we need to convert it to a production. So here we already discussed. So the transitions functions are like this. So delta of this is the current state and this is the input value and Z is the top of the stack symbol. And here these are all the P is nothing but it is the next state, and while reading A value we have this, we have the y1, y2, y3. So this is the replacement. So based on the value what we are reading, we are going to replace it with the symbols. So this is about the transition function. So here the transition functions are many. If we the production the pushdown automata having the many transition functions, how to design the productions from this transition. So here S is nothing but S is the state is changed from P to Q. So based on this transition function, so the production Q first current state is Q and the transition after transition the state is P, and the terminal A is consumed. So here what is this A in the sense the input value what we are reading. So here whenever we are reading 1, we need to replace it with the X in the stack symbol. So that is the 1 or A. Here these are the terminal symbols while reading, and Z is nothing but it is a stack symbol, top of the stack symbol. So before reading this A, what is the top of the stack symbol? So suppose here without reading this 1, so first step is this one. So that's why we have written this is the top of the stack symbol. So this is the thing we are going to represent here in the transition function. So stack symbol Z is popped and replaced with the sequence of K variables. So here this Z is going to be replaced and popped and replaced with the sequence of K variables. So whatever the replacement while reading the A value, we are going to replace it with the stack with the top of the stack symbol. So those are all represented as the various K symbols. So these are the 3 things we need to observe in the transition function. And here action. So create a grammar called QZP. So here we are going to divide this transition into a equation. So equations, how to design the productions rules. So production rules are nothing but it is a combination. So till now we have seen just only single letters. So here we are having the 2 things. So here we are having the present state and the next state. So present state and the next state we have. So we need to design the production rule in the combination of both the 2. So that's why we have to write the production rule like QZP. So current state and next state along with this one. So which includes the following production. And here this QZP which includes, so what is the terminal value? So terminal while reading A input value. So this is the present state and this is the replacement value, and so these are the next state. So in between we need to write. So how to write these equations we will discuss with the examples. So here to avoid confusion, so here bracket matching. So bracket matching example where we will discuss. Then we will discuss the question by question. Here the bracket matching. So here the bracket matching the terminal. So while taking the input value as here 2 open braces and 2 close braces. So this is the input string. To avoid the confusion open close, just write A and B. So B is for open brace and E for close brace. So, and here what is the transition function? So here while reading, so we need to, so along with this Z1, so while reading open brace, we need to push B into the stack. And how many 2 B's are there? After this one, while reading this one, so while closing brace is readed, we need to pop this one and we need to pop another B also. So this, with this we just reached the Z0. So this entire process is represented in the transition functions here. So first one is delta of while reading B input. So while reading B input, and top of the stack symbol is Z0. And now what we are going to replace? So B is replaced with Z1. So here B is replaced with Z1. So with this transition we will write Z1. And next along with the Z0. So here Z0 is already there and we need to replace the, we need to push the value Z1 into the stack. And next one, so again we are reading B, and now the top of the stack symbol is Z1, and now the top of the stack symbol is Z1, and what we have to do, we need to push again Z1 into the stack while reading the second B. So B, B. And next one, while reading E, so while reading E, so what we have to do, we need to, top of the stack symbol is Z1 and we need to pop the value of Z1. So whatever there on the top of the stack symbol, we need to pop. And here coming to this input value, again E is there. So this is how many times E is there. We need to write only one statement. So how many values are there for this E input symbol. So same equation we are writing only one time. So for E also we need to pop the Z1, and we have only the stack symbol is having, the stack is having the Z0 symbol only. So while we finish the input string, so that we have only epsilon. After finishing the input string, we have only epsilon. So epsilon, while reading the epsilon, and the top of the stack symbol is now Z0. So what we have to do, we need to move to the Q0, and with the, so this one also pop here. So this, like this, we just return the transition functions for this example, bracket matching. So that after finishing the epsilon symbol, we just reached the same state and we emptied the stack. So after emptying the stack, we are in the input string what we have given is the accepted by that pushdown automata. So here we have the input value a transition, and what we have to do, we need to convert into a production. So these are the transition functions we need to write in a production form. How we will write? See. So here the first step is initial state we need to identify. So S tends to, so Q not, so S is equal to, here we already told that. So here we need to write the equations in this form. The present state and the next state in between, whatever the top of the stack symbol is there initially. So here the first one is the Q naught, and we have in this entire thing, so we have only one state is there. So suppose here if we have a two more state, we need to write like Q naught comma Q1 in between the Z naught, like this we need to write. But in this transition function, we have only the one state Q naught. So that's why we have to present state and next state is the same thing. So that's why, so this is the S. So that is what we have written. And next one, second step is we need to write the same transition into this like this. So here Z Q1 Z0 Q1. So top of the stack symbol is Z1 Z0, and in between the current and next state are same. So we will write. And what is the input value? B. So B we need to write here, and we need to, how many values we are having in that stack. So we need to write for those stack input values with the two states. So that is a Q naught and a Q naught. And so first one is a Q Z1 and this is a Z1, Z naught. And for this equation also, so for this equation, we have the two input values we have, and while reading the B value. And here also we have the same thing we are going to replace. So here Q naught and in between Z1. So Z1 is there and next state is also Q naught. And what is the input value? Here E is the input value. So while reading E, we are replacing with the E. And same thing Q naught and Z naught is also epsilon. So what this transition diagram represent? Transition diagram. So let me write the transition diagram. So here we have only one state. So what it indicates, the Q naught present state and next state, it is also with the epsilon. So that's why we have written the initial state and final state as the same thing. So and we need to write the equations like S tends to, so B is the input symbol and we need to write Z1, Z naught and B with this Z1, Z1 and how many E is there while reading E input value and top of this and we need to write the epsilon and here while reading the epsilon we are going to read epsilon. So here this is the transition diagram what we are observed for the bracket matching. And we already constructed the production rules. So based on the transitions, how we are going to construct. So based on the current and next state values, we are going to construct the transition table. Transition productions rules. And now we'll need to simplify this one. So we'll just confuse with these two names. So that's why we'll allot names like A, B, C, D. So here while reading, so let A comma B will assume. So A is nothing but Z naught with the input top of the stack symbol Z naught and with the top of the stack symbol Z1 is represented as a B. And same thing we are going to represent in the AB form. So here S tends to A and A tends to B and BA and B tends to BB and B tends to E and A tends to epsilon. So the altogether we'll simplify those equations because we have the two B values which is having the two productions. So we'll write this one. So and also we have A S tends to A and here we need to remove this unit production. We'll just replace the A value into the S. And along and A is also having the epsilon symbol. So that's why we need like this we need to simplify the grammar. And finally while observing the transition functions we are going to convert it into a production. So this is how we are going to construct the context free grammar from the pushdown automata. And this is the one more example which was taken from the question bank. So here describe the grammar for the following PDF. So like previously we have seen only one state. So in the previous example, so we have only the state Q is equal to only Q naught is there. And if you observe that we have the value, two values are there. So how to design the context-free grammar from this type of pushdown automata we will see. And here, if you observe, this is the grammar what we have. We have the pushdown automata. So M represents the tuple notation of pushdown automata. So in this one we have the Q value. So Q is nothing but Q naught Q1 and the 0, 1 which is a sigma. So this is the sigma and this is the Q and this is the tau symbols. So what are the symbols we are going to insert into the stack? Those are all represented as a tau. And Q naught is the initial state and Z naught is the initial stack symbol and this one is a delta. So delta is nothing but a transition function. So what are the transition functions? So these are all the transition functions. So here by observing this one, we can construct the context-free grammar. So here we have the transition functions. How to design the transition functions for two input things, two states. So here we need to write first V is, so what is the grammar represent? So grammar which is having the values like VSTP. So VSTP. So how to design V here? So S is the starting symbol, so that we will design later. And S, after S we have the values like, it's the combination of two states. So here two states are there, and we have the two stack symbols. So top of the stacks, two stack symbols are there. So with this, how many combinations we have? So this is the grammar. So how to write this one? So Q naught and Q naught, in between we will write with the X value. So X. So with the top of the stack symbol X, how many states are there? So here with the Q naught X, Q1, and here we need, so initially we have only the state 1, Q naught with the self state, and here it's a combination of two states, and here first state is Q1 and next state is Q naught, and with this combination, and here both states are the both states are the Q1 states. So here, so this is one combination for the input for the top of the stack symbol X. And one more value is there, we have the Z naught. So for Z naught also we need to write like this. So here Q naught, Z naught and Q naught, and Q naught, Z naught, Q1, and Q1, Z naught, Q naught, and Q naught, Q1, Z naught, and Q. So this is the value of V. So here the V is nothing but, so V is nothing but the terminal, V is nothing but the non-terminal. So here these are all the non-terminals. So these are all the combinations of values we need to write. And here this is the first step. And the S is the starting state we have, and a T is nothing but the terminals. So T is nothing but whatever the values are there, 0, 1. And the productions we need to design. So how to design this production? So here, so while taking S tends to, so here we have the combinations like Q naught, so X, Q naught, and for this one, and also we have Q naught, X, Q1, and this is the first one, and also we have the values Q naught, Z naught, Q1, Q naught, and Q naught, Z naught, Q1. So here these are all the values. So how to design this one? So for take the first production. So S is already we have. So first transition functions we will write. So what is the first transition function? So delta of, so Q naught, so Q naught 0, Z naught, Q naught 0, Z naught is equal to Q naught X Z naught. Q naught X Z naught. So this is the transition functions, first one. So we will write the first one. So how to write? So here we have the two stack symbols here. So two stack symbols are there. So those are all two stack symbols which we are already having the tau symbols. So when we have this kind of two symbols, so 2 power 2, we require the 4 combinations. So here how to write these 4 combinations? So let me write, so S we already designed. So both states are Q naught only. So that we will write Q naught with the Z naught, Q naught, and Q naught, Z naught. So here we need to write. So top of the stack symbol. And here Q naught, Z naught, Q naught, and so Q naught. So here I will write like this, Z naught Q1, and which leads to production rules are like this. And whatever the top input symbol is there, we need to write. And here we need to design the 4 combinations for every. So for every state we need to write. So for every combination of states we need to write the production rules. So here, first step is this is the X value. So 2 inputs are there, so that we will write the 2 top of the stack symbols in between. And here Q naught and Q1, Q naught, and this is the Q naught and Q1. So these are the 2 things same. So these are all the combinations of states. And here with the combination of Q1 and Q0 and Q1. And whatever there, X is the top, in between X is there, and we need to write like this. And here also we need to write the combinations here. So here we need to write the combinations like this, Q1, and here also Q0, Q1. So here Z0 is there. So Z0, we need to write like this. And here the Q0 and Q1 and Q0 and Q1. So here we need to write, these the 2 states are same, and here we need to write, this is the Q0 and Q1, Q1, Q. So this is how we are going to design the input values. So here whenever we have the two combinations of stack symbols, we need to write like this. So here the 4 possibilities of the four possibilities of equations we need to write. And let's take one more equation. So 0 input and X top of the X symbol. So delta of Q0 comma 0 input symbol, top of the stack symbol is X, which is equal to Q0 with the XX. So what it indicates, it is pushing the value of X into the stack. So here same, we need to design 4 things. So with the input value 0, and let me write like this. So 4 things. So 4 things, first 2 are same. So with the X value here, X Q0, X Q0, X Q0. And here the input value is same. And here also 0, 0 and 0. And Q0. And now Q1 and Q0 comma X Q1. So here the combination, we have the 2 values. So X, 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 X. And now we will write the state Q0 and Q0 here. And here Q0, Q0, Q0. And Q1, Q1, Q0, Q1. And Q0, same thing, Q1 and Q0, Q1. And here the Q0, Q0, Q1 and Q1. So like this, all the possibilities of the states we have written. So this is the first X, and this is the second X. So and like this, and we have to write the 3 production rules also. So 4 production rules, like transition of, let me write the transition of Q0 1 input X. So Q0 1 input X, top of the stack symbol is X. Q1 E. So Q1 comma E is there. So here for this production, so only we have the value, only single value. So single, while having the single top of the stack symbol is there. So E or epsilon, we can write it as a epsilon. And here we need to write the combination of 2 things. One is the Q0 with the X value, and we need to write the next state. So directly we have the only single value, so that while writing directly, so current state and next state. and which is having the value 1. And one more production, this is the third one, and fourth one we need to write. So transition of Q1 1x. So transition of Q1 1x. So Q1 epsilon. So Q1 epsilon. So for this one, we need to write it is a combination of current and next states are same. So with the x in top of the stack symbol, and next state is the Q1, and what is the value of 1. So it is the input value we need to write here. And fifth one, so Q1 E epsilon x. Delta of Q1 epsilon x is equal to Q1 epsilon. So here how to write? So here we have the input value is also epsilon. So Q and present and next states are same. So x Q1 is equal to epsilon also. And sixth one is Q1 epsilon Z1. So same thing with the top of the stack symbol is Z0. So Z0 Q1 comma epsilon. So for Q1 Z0 Q1 also epsilon. So these are the values we already have for the equation. So here in this one, not all the production rules we are going to use. So in this one, in the Q1 X, this one, and Q1 Z Q naught, these are all never appear on the left hand side, so that we can directly eliminate these two things. One is Q1 X Z0 and Q1 Z0 Q0. So these we can leave aside. So and after that we have the values like every time we are having the two values. So S tends to Q0. So with the 0 input symbol. So Q0 X Q0. So we have the two values like Q0 Z Q0 and Q0 X Z0. And so here we need to write like this. So S tends to A, B, and S tends to 0, Q0, Z1, Z0, sorry, X, Z0. So here, this is the first step we need to do. S tends to A. So A is nothing but here Z0. So S tends to A. Here A, we will take it as a Q0, Z0, Z0, Q1. So here, and this Q0, Z0, Q1 tends to 0, Q0, X, Q1, and also we have the value Q0, Q1, X. So while segregating all these things, we will get this AB combination. So here this is the A. If you observe, this is the A value, and this value is equal to B. And here we have the value C. So Q1X. So here it's a combination of Z0. So Q1 Z Q1. So here, and it's a and next B value. So B value is equal to Q0 X Q1 is equal to, this is the B, and it is also having the value 0, and here this 0 is divided into this thing, and so it's a combination of A, that is nothing but B. So B is nothing but Q0 X, and this one X value. So Q1 X Q1. And one more thing, let me write the entire thing. So S tends to A, and A tends to 0, B, and this one is represented as a Q1 Z not Q1. So this one is named as a be C. So while writing as a C, so here this is the input value and C, and this one and B tends to, so B tends to, it is a combination of X Q1. So what is this X Q1 represent? B. So 0 B. So this is B, and this is the D value. And here we have the equations like, so this is the value of B. So Q naught X Q1, this is the value of B tends to 1, and this one B tends to 1, and this 1x Q1. So 1x Q1 is nothing but, so D. So D tends to 1, and this D is also having the epsilon symbol, and this one is also having the epsilon symbol. So what is this? Q1 Z not Q1. So tends to epsilon. So all together we will simplify. S tends to A. So unit, while eliminating the unit production, we have the value A 0 B C, and also we have the A tends to epsilon also there. So epsilon, so A tends to, and next one, so B tends to O B D. So and also we have the value of 1, and here D tends to 1 epsilon, and C tends to epsilon. So this is how we are going to have the grammar for the, so this is the grammar for the given pushdown automata. So this is the example. While we have the input values, two stack symbols are there. So one stack symbol is there. We need to write the present state and with the combination of present state and next state values. But here we have the top of the stack symbols. Two stack symbols are there, so that we need to write all the combinations, and we need to remove based on the rules like whether it is appearing in the left hand side and right hand side in the grammar or not. So this is how we are going to convert the given pushdown automata into a context free grammar. So these are the references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.